Welcome to my chemistry lesson. Today we are going to discuss about the chemical equilibrium. So what is meant by a chemical equilibrium? A chemical equilibrium is a state of a dynamic balance of a chemical reaction in which both forward and backward reactions have same rate. So normally a chemical equilibrium is represented with a double arrow. So another important point in a chemical equilibrium, the both forward and backward reactions are taking place in the same rate. So for example, I have taken a very common example that is N2,3H2, 2NH3. That's a formation of ammonia from nitrogen and hydrogen. So in that reaction, N2 plus 3H2 gives 2NH3. This reaction has two directions. The one is a forward step and another one is backward reaction. So the delta H of that reaction is minus 96.3 kilojoule. So that means that the formation of ammonia is an exothermic reaction. So here the two steps are the formation of ammonia and at the same time the decomposition of ammonia into nitrogen and hydrogen taking place. So that's why we are calling this is an equilibrium reaction. So here I would like to say a simple example how we can understand an equilibrium very simple form. If you have a glass jar containing 100 ml of water, if you take from that glass jar 20 ml, if you pump out 20 ml from that jar, so the rest of the volume of the water is 80 ml. You can see to the glass. So and we pump into the jar again another 20 ml. So again the volume made up into 100 ml. So these two processes, the pump out and pump in, are under different time and different rates. That's why we recognize the change in volume in the glass jar. So if you set up a system like that, if you pump out 20 ml in a particular speed in a particular time, at the same time if you pump into the jar that same 20 ml with the same rate and same time. So if you observe that process, two individual processes are taking place. There is a pumping out and there is a pumping in, but we can't recognize any change in volume in the glass jar because both processes are opposite and they are taking place in the same speed. This is exactly same in the case of the chemical equilibrium. So reactants are converted into products at the same rate and same speed. The products are decomposed into reactants. So that's why in that particular state we will feel the reaction is stopped, but it never be stopped. That's why we are called chemical equilibrium reaction is a dynamic in nature. So here I would like to discuss for properties of chemical equilibrium. The first point is at equilibrium no change in concentration of reactants and products take place. That means all the time once an equilibrium state exists, that means the concentration of reactants and products are same. The second point is both forward and backward reactions are happening. That's not stopped. That's why we call it as a dynamic in nature. And the third point, the reactants and products are always present in that equilibrium. There is a certain amount of reactants and there is a certain amount of products will remain all the time. And fourth point, the concentration of products depends on the condition of reaction and the reaction itself. So the next one is Le Chatelier principle. So what is a Le Chatelier principle? According to Le Chatelier principle, if you try to make a change on an equilibrium system, the system will try to cancel the effect of that change by shifting or changing the speed of either forward or backward reaction. So what is system here? The system means an equilibrium system. And what is a change? The change is any kind of changes in concentration of reactants or change of the pressure, change of the temperature. So according to Le Chatelier principle, in an equilibrium system, if you try to make a change in the concentration of reactants or change in pressure or change in temperature, then the system will try to cancel the effect of that change by shifting the equilibrium either forward direction or backward direction. So here I have used very common example, the formation of ammonia from hydrogen and nitrogen. So we are going to discuss what will be happen when we change the concentration of reactants and what happened the change in the temperature and what will be the effect if you change the pressure. And the fourth point, what will happen if you introduce the catalyst. So here N2 plus 3S2 gives 2NS3. This is an equilibrium that shows a double arrow. So here the effect of concentration we are going to discuss. For that we number the total number of reactants on the reactant side. There is a 1 mole of nitrogen and 3 moles of hydrogen. So total 4 moles of reactants. And on product side there are 2 moles of ammonia. So if you increase the pressure, we know the pressure and volume are inversely proportional. If you increase the pressure, the system will try to decrease that pressure by changing the equilibrium into low volume side. That means if you increase the pressure, that will help to increase the formation of more ammonia. So by increasing the pressure of equilibrium, we can increase the production of ammonia. The second point is, what is the effect of temperature? So when we see the equation NS2 plus 3S2 gives 2NS3, in that case delta H is negative 96.3 kilojoule. So that means the forward step, that means formation of ammonia, is an exothermic reaction. So that means during the formation of ammonia from nitrogen and hydrogen, there is a liberation of heat. So if you try to increase the temperature in that equilibrium, the system will try to reduce that heat by shifting that equilibrium in the direction of absorption of heat. That means that will enhance the backward reaction. That means decomposition of ammonia taking place if you increase the temperature of that particular equilibrium. So on increase of temperature, you will get very minimal amount of ammonia, because in that case the forward reaction is exothermic reaction. So third point is what happens to the pressure. As I said earlier, if you increase the pressure, the system will try to reduce that pressure by changing the equilibrium towards low or minimal volume side. That means if you increase the pressure, the equilibrium will move into low volume. In the side of products, there is 2 moles of ammonia. That means less volume compared to reactant side. There is 4 moles of reactants. So if you increase the pressure, the system will try to reduce the volume by shifting the equilibrium towards into ammonia side. So what is the role of catalyst in an equilibrium? A catalyst has no position on equilibrium, but the catalyst will help to attain the equilibrium state very quickly. So another point is the effect of pressure on an equilibrium only relevant when the reactants and products are on gaseous form. So there is another example. Hydrogen plus I2 gives 2Hi. Hydrogen plus I2 gives 2Hi. So that means we can discuss the same things what we have discussed earlier in the case of ammonia here as well. So for example, if I'm just trying to explain what happens if you increase the amount of iodine on that particular equation or reaction. What happens? If you increase the amount of reactants, that the system will try to reduce that amount of increase, then more products will be formed. That means it will enhance the forward reaction. So we'll get more hydrogen iodide as a product.